Okay, I'm going to go over the last couple of questions we have on our momentum and impulse study guide. So we've got a truck. It has a mass of 2,000 kilograms. It's traveling at 15 meters per second, and it hits a pile of marshmallows. How fanciful. And comes to a complete stop after 1.5 seconds. So, what is the initial momentum of the truck? We can get that by using momentum equals mass times velocity. So our mass is 2,000 kilograms. Our velocity is 15 because it tells us that it's traveling at 15 meters per second. So we're just going to multiply 2,000 by 15. So let's turn my calculator on. 2,000 times 15 is 30,000. And that's kilograms times meters per second because I'm multiplying mass in kilograms times velocity in meters per second. How much force is needed to stop the truck in 1.5 seconds? Okay, so remember that impulse is force times time, okay? And then that's also equal to our change in momentum. So mass times our change in velocity is usually the way we're going to look at that. So if we apply a force over a time to an object, then we're going to be changing its velocity most likely, and therefore its momentum. And so this combination is equal to that change in momentum. Okay. So we are going to solve for force. We don't know force. So that means we're going to divide both sides of this by time. So we end up with force equals mass times final velocity minus initial divided by time. Okay. My mass is 2,000 kilograms. My final velocity is 0 because I'm coming to a complete stop. And my initial was 15. So I've got 0 minus 15. And then 1.5 seconds is the time they gave us. So we're going to have 1.5 seconds. So that equals, let's see, 2,000 times 15, because it's 0 minus 15. So there's really minus there. I'm going to worry about that in just a second. 30,000 divided by 1.5 gives me 20,000. That's going to be in newtons. We usually show forces as absolutes. Okay, the negative there is really telling us that the object's coming to a stop. So when it hits the pile of marshmallows, its change in momentum is it's been moving and now it's coming to a stop. So I would leave the negative sign off here, just because this is just a value of force. When we look at the truck's change in momentum, we really kind of calculated that, but that's where our negative can come in. So we're going to have our change in momentum is mass times final velocity minus initial. Again, we really just did that here. 2,000 times 0 minus 15. And then when I multiply that out, again, I'm going to get 30,000. 2,000 times 15 equals. But that's going to be a minus 30,000. And again, that's kilograms times meters per second. So our truck had an initial momentum of 30,000. Then it came to a stop. So when you're at a stop, your velocity is 0. You don't have any momentum. So really, its change in momentum was that it lost all of its momentum here. Okay. And then that would be equal to this times time. If we look back at our impulse equals force times time, and then that equals our change in momentum. Okay, last question. During a collision between two objects, one object loses 10 kilograms times meters per second of momentum. what happened to it, what must be true of the momentum of the other object. So momentum is conserved. There's no information here to tell us that this is not a closed system. So we're just going to assume that we've got a closed system here. So we're going to have momentum is conserved. So that 10 kilograms has to have gone somewhere. It's got to stay within the system of objects, the two objects that are colliding, because momentum is conserved. So what that means is that if one object lost momentum, the other object gained that momentum. Okay, so what happened to it? It was gained by the other object. And so the other object gained momentum. Its momentum went up. I'm just using P for short there. So if one of them loses, the other one gains, so that we can keep that total the same before this collision as after this collision. So, all right, that is it for momentum and impulse.